So follow the same step. Okay, we try to factor, right? These questions needs factoring. And then find the answer in domain first. Okay, if you want to factor, you need to make one side equal to 0. So question E. Okay, we move everything to one side. It looks like 2 tangent cube. The cube x, you can think of it as tangent x to the cube. Okay, that's what it means when there's a little exponent in the middle. Minus tangent x equal to 0. Okay, so how do we apply factoring for this one? Okay, if I want to factor this, how do I do that? See that?
Factor out a 10x.
Yeah, very good. Okay, so I take out the tangent x. Can you tell me what's left then?
2 10 squared minus 1.
Yep, minus 1. Okay, good. So once you get to here, right, you factored it, you can split into 2 parts. Okay, one part will be tangent x equal to 0. The other part is the second bracket minus 1, okay, equal to 0. So I'll let you take over from here, okay? From each side, please find the 2 answers, okay? Find the angles in domain. So angles in domain. Okay, and then we are going to write out the general solution. Okay, once you got to angles in domain, you can raise your hand. Okay, we'll go over the general solution together. Okay, Daniel. This one you might need to use a calculator for the right side, okay? Because the angle is not special, okay? You will need calculator to get the reference angle. Remember this one we need it in radian, right? And our domain is not 0 to 2 pi this time, okay? Be careful, this is our domain. Domain is only 0 to pi. Okay, please raise your hand if you found the angles in domain. Okay, Nick, what are your answers?
For the tan x equals 0, I got pi and 0.
Pi 0.
Actually,
Okay,
not pi, because pi doesn't work because it's not um equal to.
not in the domain. Okay, good. Good observation. Okay, what else? And then the other side?
For the other side, I'm not sure if it's right, but I got um uh,
Yeah, it disappeared.
I think because like I think it's is it undefined because like when you have -1/2 and then you gotta like like take the square root of it, so you can't take the square root of
How
it.
did you get -1/2?
Oh, it's +1/2.
Yeah. Okay. If you
Oh, okay.
move it over, right, tangent square x will be 1/2.
So should the answer be like a decimal?
Yeah, this one is not special.
Okay,
You
so I
have
got x is equal to 0.615.
anything else?
No.
Okay, so two answers.
Yes.
Okay, thank you. Okay, anyone else? If you finished the question, please raise your hand. Just up to angles in domain, okay? Eric, what do you have?
For which one again?
For angles in domain,
Oh, I have the same.
just two? Two answers?
Yeah.
Okay. How about you, Philip?
Do you hear that? Was I
What?
muted?
Yeah, now I hear you.
Wait.
Okay.
Actually, arrow plus and minus.
What did you say, Eric?
Arrow plus and minus for the second one.
You mean plus minus 0.615?
Yeah.
So 0 and 0.615, negative 0.615.
Yeah.
Okay. And Philip, what's your answer?
I did something wrong.
Okay. Anyone else want to add in to the answer? Okay, let's go over the left side. Okay, left side is the easier part. Tangent x equal to 0. The moment that you see tangent x equal to 0, you have to remember it's on the axis, right? So it will look like it will be 0 and 0 on the right side and left side, right? Because for tangent is NA in the middle, right? Undefined in the middle, 0, 0 on the side. Okay, so in the domain is 0 to pi only, and it does not include pi, right? You see there's no equal sign. It's just less than pi. There's no equal, right? So we're looking for all the answer from 0 to pi. So from the left side, we have our first answer, right? 0 and pi. Right? We have x equal to 0 and pi, but we cannot include pi because of the domain. Okay, so we have our first answer, x equal to 0. Now for the right side, if I want to find tangent x, I need to square root it, right? So tangent x will equal to plus minus. The moment you put square root on, you need plus minus. So 1 is opposite, right? Adjacent is root 2. So this one is not a special, okay? So which quadrants are the angles for this one? Angela, where do we draw the angle? Angela? Can you hear me, Angela? Are you there?
Oh, sorry, hello?
Yeah, where'd you go?
Oh, I went to get water.
Oh, okay. So did you draw the quadrants for the right-hand side? Which quadrants would have the angles?
The first and the third one.
First and third one?
Oh, wait, sorry. For the positive, the first and third one, but then the negative, the second and fourth.
Okay, okay, very good. Then let's separate it then. All right, so we have the positive will be first and third. For the negative will be second and fourth. Okay, now because the ratio is not special, we need calculator to get our reference angle, right? So theta r is tangent inverse, and we put in the ratio. Ratio, you cannot use negative numbers, okay? If you want to find reference, only positive ratio inside, okay? And make sure you're in radian. So what's the reference that you got? Okay, Evan, can you tell us what's the reference angle here?
Oh, 45.
No, it's not 45. This is not special. You need calculator for this. Okay. This is not 1 square root 2. Okay. The 1 is opposite. Adjacent is root 2. It's not 1. Okay. This is not a 45-degree angle.
This is 63.43.
In radian, can you change the calculator to radian? The domain is radian. We need everything in radian.
I'm not quite sure how to change it to radian.
How do you change to radian? I think there's should be a button for second or shift,
Oh, because I'm using my phone's calculator.
or degree, right? You either see a D for degree, right? And then you, or DRG to change it.
Give me a second. Let me get my real calculator.
Okay. Okay, Evan, have you got it?
Oh, I can't find my calculator.
Oh, okay. Okay. Sophie, how about you? Do you have a calculator?
No.
You mean no, not at home, or
Yeah, not at home.
oh, okay. Susan?
24.9 degrees, which runs to 25.
Can we do radian? We need radian here. Domain is radian.
I'm not sure.
Change your calculator mode to radian first. Do you know how to change the mode?
Yes.
Yeah.
0.615.
Okay, 0.615. Thank you. Okay, so the reference angle is the one inside the triangle, the green dots. Those are the 0.615. Okay. But we are only interested in the ones in domain that fits in domain, right? 0 to pi. So the first one is in quadrant 1, right? The second one is in quadrant 2. Other than that, they are outside the domain, okay? If the domain is 0 to 2 pi, then you should get 4 answers, okay? From this side. But because the domain is only 0 to pi, you only list out 2 answers. So first one from the quadrant 1 is 0.615. Okay, and then how do we get the second one then, Eric? Eric, how do we get the second one?
Mm,
The one in the second quadrant.
That would be, we take this away from 180, right?
From pi, you have to use radian.
So that's like 2.7 something. No, not 2.7.
2.525.
2.525.
Okay. If you round it, should be 2.526. Okay, so we have 3 answers that fits inside the domain. Okay, now think about how many general solutions do we need? Okay, when you think about general solution, you have to forget the domain, okay? Forget about the angles in domain. You look at the pictures. Look at these 3 pictures. Right, the 3 pictures that you drew, to think about how many general solutions we need. Because total you have 1, 2, 3, 4, 5, 6, 6 arms, right? You have angles in 6 different places. Does that mean we need 6 general solutions? Okay, so write out the general solution for this one. Okay, when you got a general solution, please raise your hand.
Jason, how do you get 2.526?
Okay, the 2.526 is for the angle that's in second quadrant. Draw on the side. This one.
Mm-hmm.
Okay, that green, the green dot is the reference angle. How big is the reference angle?
Like less than pi over 2?
Yeah, but we found it, right? How big is the reference angle?
0.615.
Yeah, 0.615. So how do we find the red part? Because half a circle,
know.
half a circle is what?
180.
In radian.
Pi.
Pi, right? So part of it, right? The green part we don't want, 0.615. So the red part, how do we find that part?
Oh, you subtract the 0.615 from
Yes.
3.14, whatever.
Yeah.
Okay.
Okay. So pi minus 0.615. Okay. So usually we use degree, right? Then it will be 180 minus the reference. But here we're using pi. Okay.
Got it.
Yeah. All right. So how many general solutions do you think we need, Daniel?
Three.
That's right. Very good. How do we know we need 3?
Because I would say it's just you don't need 2 pi over like plus 2 pi over n, just pi over n because it's like half, I guess.
Okay, because they make straight lines. Okay, so we don't need 2 pi n. So you look at the left side, right? The 2 arms, they make straight lines. Quadrant 1 and 3, they make straight lines. Okay, whenever you have arms that makes straight lines, then you could use pi n to cover both sides. All right. So for the left side, you have 0 plus pi n, so you just have pi n. And then for the second picture, okay, you can start with 0.615. That's in quadrant 1. Plus pi n. That will cover quadrant 3. okay? And then for quadrant 2, 2.526, you can add pi n, and it will cover quadrant 4. Okay, so these 3 will be enough to cover all these 6 arms. Okay, and don't forget we need n as integers. All right, so can you raise your hand if you got down everything here? You need to know how to write the general solution, okay, in order to do the bottom questions. Remember, for straight arms, okay, if 2 lines they make a straight line, you use pi n. If it bends, okay, then you can then you need to use 2 pi n. Okay, please raise your hand if you finish writing down. Okay, we have one more question to cover, okay? Okay, so we are going to do method 3. Okay, probably not too much. So for the homework, I'll give you simple ones, okay? Using the method 3. Okay, Marcus and Jocelyn, are you ready? So method 3 is called the substitution. Okay, PGG. PGG, I'll explain what that means later. We'll use when, okay, use when there is a number other than 1 before x or before the angle, okay? Before x or before theta, okay, whatever the symbol they use. So, okay, please write that down first. Okay, if you look at other questions, right, before the x, always just 1, right? Cosine x, cosine square x, only 1x. Tangent cube x, right? All the question we've done before is only 1x. But the question we're looking at, right? Instead of 1x, we have 2x, right? There's a number. Okay, this is not 1. Okay, it's a 2x. So when you see something like that, you know you need to use method 3. Okay, for example, question H, right? You have a 2x, you have a 2x. If you look at next page, you have 3x, right? This one, question J, has a x over 4, right? It's not just x. Then you will need to use this method. Okay. So the part where we need to do substitution is to replace the 2x first. So sub, okay, so step 1, we sub the 2x with a different letter, okay? So we'll choose A here, okay? So if I do that, then the question now looks like 2 sine A equal to 1. So from here we can just do what we did before because there's no more, it's no different from other questions, okay? So it starts to solve for sine A, isolate sine, okay? And then find the angles, okay? So please find angle A. All right, so I'll let you find angle A right now. All right, raise your hand when you found angle A. I think we should adding the step here. Okay, let me put it here. So step 2, after you sub it in, find angle A. Okay, so please raise your hand after you found the angle A. This one is special, okay? Reference angle is special. So easy to find. You don't need calculator. So find angle A equals, there should be 2 answers. Okay, let's take a look which quadrant, okay, should it be in. Okay, Callum, which quadrant has the angle?
Quadrant 1 and 2.
Yeah, very good. Quadrant 1 and 2. Okay, sign is positive in quadrant 1 and 2. Okay, and the next thing we need to check is the reference angle, right? Ratio is opposite over hypotenuse, opposite over hypotenuse. All right, what's the reference angle here? Nick?
Pi over 6.
Yeah, pi over 6, it is. Okay, if you found the 2 angles, please raise your hand. We only have 5 people, got it? All right, Waylon, what's the first answer?
Pi over 6.
Okay, and the second one?
5 pi over 6.
Very good. Okay, so this part, I hope no one has trouble, right? This is old stuff. So these 2 angles, let's give it a name, okay? We'll call these 2, because it's the normal thing that we do all the time, right? Find the 2 angles in the within 0 to 2 pi. Let's call them the principal angles. Okay, meaning they are the main ones, principal angles. Okay, principal angle is all the angles that's from 0 to 2 pi. Okay, and get those 2. So once you get here, next part, I would like you to write out the general solutions for these principal angle. All right, so general solutions. Okay, for the A. So A equals. Okay, so please write out the general solutions. Okay, these 2 arms, right, quadrant 1 and 2, they don't make a straight lines, right? So you will need to use 2 pi n, okay? You cannot use pi n. So please write out the general solutions and raise your hand. Okay, you should be done by now. All you need to do is add 2 pi n, right? Are you guys done? Okay. So Chris, what's the first general?
Pi over 6 plus 2 pi n.
Yeah. And the second one?
5 pi over 6 plus 2 pi n.
Yeah, very good. Okay. And then of course we need n as integer. Okay, make it a habit. Don't forget that. So this is the general solution for A. And remember A, at the beginning we substitute the 2x for A, right? So that means A is actually double of what we want, right? We want to find x, not 2x, right? So to find x, you need to take your A divided by 2. Because A is 2x, so x is A divided by 2, right? A is double of x. So the next part, we need to modify our general solution. Okay, this time is the general for the x. So to go from A to x, we need to divide each one of these two by 2, okay? Divided by 2. So what does pi over 6 divide by 2? Sophie? Sophie, what does pi over 6 divide by 2?
Sorry, can you hear me?
Yeah, I can hear you now.
Okay. Is it pi over 12?
Yeah, so you get pi over 12, okay? And then 2 pi n divided by 2. What's 2 pi n divided by 2, Marcus? Marcus?
Oh yeah, sorry, what?
Yeah, 2 pi n divided by 2.
This is pi n.
Yeah, so you will add pi n. Okay, you take the original answer, right? Answer for the A, you divide that by 2, so you get the answer for the x. Okay, because the A is 2x, but we want to find x, you need to divide by 2. So you do the same thing for the second one, the second general. All right, so you will have what, Angela? What's the general for the x? Angela? Yeah.
Sorry, how do you get rid of the 2 again?
Get rid of 2.
Oh, like make it pi n?
Yeah, so you divide the general solution by 2. So 5 pi over 6 divided by 2, 2 pi n divided by 2, right? All the whole thing divided by 2.
5 pi over 12 plus pi n?
Yeah, okay. So it's not always divided by 2, right? This one, for this question, we divided by 2 because 2x equal to a. At the beginning, we let 2x to represent a to help us find a first. But we need to, our goal is to find x, right? So a is double the value of what we want. So we need to take the answer for a and divide it by 2. Okay, can you raise your hand if you understand why we divide by 2? So if it's 3x, you need to divide by 3, okay? If it's 5x, you need to divide by 5. All right, so depending on the question. Callum, Eric, Marcus, and Nicholas, any questions? Okay, so this is general for x, right? Now we can use these ones to help us find the angles in domain. Okay, now this is the domain. The domain is everything that fits inside 0 to 2 pi. Okay, so rather than in domain. So we use the general solution that we just got. which is here and here, right? We have two of them because it represents any answer, right? So you can use those two like a formula to generate all the answers. So you can start with the red one, okay? If n equal to 0, then you get our first one, pi over 12. Okay, when n equal to 0. When n equal to 1, that means you add a pi. Okay, so think on the side, pi over 12, if you want to add a pi, you need to get common denominator, 12 pi over 12. So that makes 13 pi. Okay, so each time you add a pi, you add a 12 on the top. Okay, so 13 pi over 12. So that one is still less than 2 pi, right? Because 2 pi is like 2 pi is the same as 24 pi over 12. You cannot go over 24 pi over 12. Okay, if I do one more, if I add another 12, it will be 25 pi. And that will be too much. Make sense? Okay. So you move on to the green part now. Okay, for the green, when n equal to 0, you have 5 pi over 12. This one is still under 24, right? Under 24 pi over 12. You add another pi, so that will give you 17 pi over 12. It's still under, okay? Now if I add another one, you get 29 pi over 12, but then that will be too big, so you cross it out. Okay, so at the end, your final answer for this questions is these four. So that's why you need to know how to get your general solution. Okay, it's all based on that. All right, a little bit complicated here. Do we have any questions? How we get each of the four answers? If your domain is bigger, then you get more answers. This one, the domain is up to 2 pi, so you only go up to 24 pi over 12. Okay. If the domain is like 3 pi, then you go up to 36 pi over 12. Okay, so why do we call it PGG, right? PGG is the P stands for the principal, right? P. G is the general and general. Two generals, one general for the A, one general for the X. And then you use the final general answer to find the domain, okay? The angles in the domain. So I'll pick a few questions like this, okay, for homework, something that's not too complicated. So if you look at the homework page, it'll be probably question like, okay, like this one, right? Sine 3 theta, right? Like this one. Okay, cosine 6 theta. Okay, I think I'll be picking those four for your homework as well. Okay, so if you still have question about the method 3, okay, you can stay after class or anything else. Okay, and please hand in the homework before you leave. Jocelyn, Marcus, and Evan. Okay, and everyone else. Next week we don't have class. Okay, next week is have family day, weekend. So you guys enjoy the weekend, right? I'll see you the week after. Okay, bye-bye everyone.
Hi, Jason. Thank you.
Bye, Jason.
You're welcome.
Thank you, Jason.
See you.